Using ESurvey CAD, contours can be created with .csv file, or we can generate the contours within CAD package itself. Generating contours within CAD package. We will open the sample drawing file which has elevations and a boundary. Before generating the contours, we need to set contour generation preferences. This can be done by selecting Contour Setting option of Contour sub-item in ESurvey CAD menu. In Contour Settings window, we can specify parameters like contour interval, grid spacing, boundary generation factor. For this example, let us set 0.5 as contour interval. We will specify major lines for every 2 meters. Select Smooth Contours from Contour Lines group. We will specify 5 meter as grid interval and grid line spacing in Grid and Elevation Lines group. Since we will be selecting the boundary for contour generation, we will not make any changes to scanning radius in Contour Calculation group. We will select Contour, Grid, Grid Elevations in the Output Layer group. We will save these settings by clicking on Apply button. In the next step, we will select Generate Contours menu item. Now, the software will ask for selecting elevation text. We will select all the levels in the drawing and then we will select the boundary when application prompts for the same. Now, we can see that application has generated contour, contour annotations, grid, grid elevation, grid annotation all in a single command. Generating contours using ESurvey CAD is that simple. We can also generate contours with multiple boundaries, islands, break lines, etc. We can also create 3D surface while creating contour. For generating 3D surface, we need to select 3D surface in a contour setting window. When we generate contours by selecting this option, we can see that thin surface gets formed, which can be viewed in 3D in CAD package by setting required UCS by selecting View Look from option. We can also render better 3D view by using a shade command in CAD package. Generating contours in ESurvey CAD interface. We can generate contours in ESurvey CAD interface itself. First, we need to create a file. Let us create a file by name Contour Sample by selecting Topo, Contour, Earthwork option. To import elevation, we have to select CSV or Excel file from Import Data item of Surface menu. We have to specify column numbers of serial, easting, northing, elevation and remark as an import file. By clicking on the Import button, elevation data will be imported. If we have boundary data in CSV file, even that can be imported. In this demonstration, we will create boundary using the software only. Open Contour Map window from Contour menu. To create an automatic boundary from elevation data, we have to specify the appropriate scanning radius. Scanning radius is a factor which you need to specify to help the software compute the boundary. You need to specify the maximum distance at which you have taken elevation during the survey. In Contour Lines group, we will specify the contour interval and difference of elevation for major lines. Say 0.5 meter is contour interval and 2 meter is the interval between major lines. Along with contour generation, we can also create grid levels. So let us select grid interval in elevation grid tab. Say 5 meters. We have to select items which we want to output in display layers group. Let us select contour, boundary, original elevations, contour annotations, grid and grid elevations. Now by clicking on View button, contour map will be created, which can be exported as a CAD drawing by clicking on CAD button. The software also displays elevation statistics, which includes minimum elevation, maximum elevation, number of contours, area of boundary. For better results, we always recommend that you import boundary instead of allowing the software to decide the boundary. In this video, you will come to know how easily survey data can be imported as drawing with automatic line joining, block insertion and much more. Many of the surveys are done either with total station, GPS or DGPS. Most of the total station survey instruments come along with softwares which convert the surveyed data into drawing format, either a drawing file or a DXF file. The point created by such programs represents a point with an attribute block, mostly as a 3D point, which makes it difficult for the users for further editing of the drawing. TopoDraw addresses this problem and automates drawing conversion and generates output in 2D or 3D as per user requirement. The output file from the total station or any other instrument capable of capturing the coordinates and elevations will have serial number, easting, northing, elevation, and remarks. Remarks are also referred as a code. For example, a code BW represents a borewell point. We will convert one of the existing point data files to help you understand this program. In ESurvey CAD, you need to create a new file by selecting TopoDraw, Contour, Earthwork option by giving any file name. In Surface menu, go to Import Data and select the surveyed data file. Data can either be in CSV or Excel format. All the survey instruments not necessarily will have point data in serial, easting, northing, elevation, and remark order. In case if point data is represented in different order, we can configure importing by altering the column number in this import window. Once you configure columns correctly, you have to click on the import button to import the data. Now we will select TopoDraw menu and select Topo Map item, which will display the output CAD file where each point from point data is represented with serial, elevation, and remark. We can note that the remarks are overlapping with serial number. To make the drawing more readable, we can configure text representation properties in the configuration window. In this window, we can make many modifications related to point property display like position, output point in 2D or 3D, etc. To remove the overlapping, we will give shift value as -1 for remark, which means that the text representing remark will have to move downwards by 1 unit. After making these corrections, if we generate the drawing by clicking on View button, we can note that drawing readability is enhanced. By making changes in configuration window, we can set more properties like display of the particular point attribute like X position, layer property, representation in 2D or 3D, etc. Line joining and block insertion in TopoDraw. To automatically join lines using TopoDraw, we have to click on Setting button and click on Add Remarks. The software will show all the remarks, that is, unique remarks available in your point data. We can import all of them or import selectively. Let us import all of the remarks in this demo session. We can note that the software will display all the remarks with details like number of time that remark is present in point data. In this example, D1 and D2 represent drain lines. There are 42 points representing first drain edge, and similarly D2 represents the other line edge. To automatically join all the drain edges, we will select Line option and select Join Tech option. After making these changes, if we refresh the drawing by clicking on the View button, you will note that all the remarks representing drain are automatically joined. Note that in the drawing, blocks are inserted. When we have imported codes in setting, software has identified blocks which matches with given code. For example, we have a code by name EP which represents an electrical pole. EP.drawing is present in C:*ESurvey, ESurvey CAD blocks folder. Similarly, other blocks like tree, borewell are inserted. When you start using the software, you can also add such drawing for a new set of remarks to this library or replace these blocks with your own blocks. This demonstrates that drawing preparation from total station survey data is very simple with TopoDraw. Further, to highlight a few points in TopoMap, you can select Box Remarks with RL and save it. When we refresh the drawing, you can see for that particular point, marking is also done. Finally, Check on the CAD button to convert your total station data into your CAD package and easily edit the drawing as the entities created are plain text entities and simple CAD blocks. Calculating earthwork quantities for site surveys, which is also referred as grading, can be achieved using this module. Earthwork quantity for roads and canals can be estimated with section module. Earthwork calculation can be computed either using CSV file or CAD data. In this video, we will compute earthwork quantity from a CAD drawing. Computing quantities from CSV file is also similar. In this sample drawing, there are two sets of data. Elevations, which are represented by green colored text, represent ground elevation, and one in orange represents formation level. Earthwork calculation can be done in ESurvey CAD software interface. We have data in CAD drawing, so first we need to export these data to ESurvey CAD module. Select Export Ground option in Earthwork item of ESurvey CAD menu and select all the elevations which represents ground elevations. Similarly, we will export formation levels. You may please note that exported data will be saved as a CSV file and will be stored in temporary directory C:"esurvey temp as ground.csv and formation.csv. We will export the boundary also by selecting a closed polygon representing the boundary. Now 3 sets of data is exported. We will create a new file in ESurvey CAD by selecting Topo, Contour, Earthwork option with name Demo Earthwork. We will import ground data by selecting Import Data under Surface menu by locating ground levels from ground.csv stored in C:"esurvey temp directory. In the next step, we will import boundary data by selecting Import Boundary option under Surface menu. After these imports, if we select Earthwork menu item from Earthwork menu, we can view imported data. We can see ground levels and boundary by clicking on View button. Earthwork calculations are done by converting input data into grid levels. So first, we need to specify the grid interval by selecting Grid tab. When a new file is created as a default, grid interval will be 10 meters. We will set it to 5 meters for calculating earthwork. In Display tab, we can control which levels we want to see in the drawing. Let us select grid elevation of ground and formation levels. For computing earthwork, 2 sets of data is required: base surface levels and the comparative levels. We have ground levels as initial levels. If we look at base surface statistics, we will come to know that in this surface model, minimum level is 17.10 and maximum is 29.959. We can give single level as the formation level, that is, a plane with the given formation level is created as a surface. In Computation tab, we will specify 25 as formation level. Now, if we click on Volume button, software will compute cutting and filling quantities and show the result instantly. Volume calculation result is summary of computation. To understand the detailed calculations, let us click on View Cross-Section button. In Calculation and Drawing window, we can have a look at each cross-section that is derived from grid. Note that software has calculated area for each of the cross-section. If we select Volume tab, we will come to know that volume calculation is done considering the area values derived from area calculation of each cross-section. By clicking on Report button, we can generate the volume report in Excel. When submitting earthwork calculation report to client, not only a volume calculation Excel sheet is required, but also we need to generate all respective area calculation and cross-section drawings. Earthwork module allows you to generate all required drawing and calculation sheet with single command. Select Drawings and Reports from Earthwork menu. In Drawings and Reports window, we can select required outputs like drawings, plan, area report and volume report. We can select all drawings in single file option and select single row. we need to specify a folder name. Let us say Demo. When we click on Generate button, software will generate all the drawings and reports. We have computed earthwork calculation with single formation level 25. Initially, we exported formation levels also. If we have to compute earthwork using exported formation levels, then we need to import it via Import Formation item available under Earthwork menu. After importing formation levels, you may note that option to specify formation level is disabled in Earthwork window. Calculation and output generation methods remain same when we have import formation levels. Till now, we have computed earthwork using a method called section method. In this method, software converts elevation data into grid levels and then it creates cross-section for each row of grid data and then finally computes the volume using trapezoidal method. In this earthwork module, calculations can also be done with another method called block method or division of square method. Calculation of earthwork by taking averages of ground levels and formation levels is the shortest method to compute the volume. However, that method gives inaccurate results. However, if the whole area is divided into smaller blocks and then if we compute volumes by taking average, it will give better results. Click on Block button and select Average item under Ground and Formation and let us select Area, Block Boundary, Block Number and Block Volume. When we click on View, we can note that for each box, volume calculation is done separately. These boxes are formed depending upon the grid interval we have specified, that is 5 meter in the demonstration. Software is finding the average of base surface levels and comparative surface levels and it is multiplying the difference in the averages with area of that particular block to derive the volume of that particular block. By clicking on Report button, an Excel sheet with details of computation will get generated, which will have block number, all the initial levels, average, final levels and their average, area of that particular block and finally volume of that block either in cutting or filling is displayed. There are 3 different types of interpolation available in Interpolation module. In this video, interpolation using tin is explained. In this example, we have alignment which represents the center line of the road. If we want to interpolate the levels on either side of this line, we have to offset the center line. In this example, we will offset center line by 3 meters, thrice on either side. That means we are interpolating values up to 9 meters on either side. Using MCH command, we will mark chainage lines along the alignment at 25 meter interval. For interpolating values, center line needs to be in longitudinal section layer. Lines representing offsets need to be in offset layer and the elevations representing the surface data need to be in elev layer. Once the offset line, elevations and center lines are moved to required layers, we can interpolate values alone with cross-section. Select ESurvey CADD. Interpolate using tin methods. At cross-section, L-section offset line, that is command ITI. Select any CS line. You can see that software has interpolated the levels at LS, offset intersection. If we select all the cross-section lines in ITI command, ESurvey CADD will interpolate the values all along the alignment. These interpolated values can be further used for creating cross-sections. In this video, you will learn how to easily create cross-sections from survey data, design cross-section template, define formation level, and create cross-sections with area calculation and print the sections. You can also learn how to generate volume calculation in this video. Create a new file. Open ESurvey CADD, select File, New, specify project name, say Road Sample, and create a new file by selecting Sections option. Importing data from Excel. For understanding, in this video tutorial, we will import data from field book format. Open C: ESurvey, ESurvey CADD, sample, field_book.xls. You may note that in this format, you have to give serial number, section number, foresight, interim site, backsite, collimation level or height of instrument, and distance or offset. The software will automatically calculate the reduced levels while importing the data. ESurvey section allows you to import data from 5 different types of Excel formats: layers, series, classic, fixed distance, and fieldbook. Click on Excel Import button and select fieldbook.xls file. Once the data is imported, all the cross sections will be created automatically. You can navigate from a cross section to cross section in the preview screen. Cross section and longitudinal section settings and navigation. Note that the cross sections which are generated are in the scale 100:100. That is 1:100 on horizontal scale and 1:100 in vertical scale. ESurvey section offers you many settings using which you can modify the cross section to great extent. You can change the scale, header, footer, projection lines, layer names, color, and font property of each item of the cross section. You can enable graph, you can choose to hatch the area calculation layers, and much more. We will make some small setting like changing caption in footer, changing datum precision to 1, change layer 1 caption as ground levels, and enable project line to layer 1. Now you may observe that all the cross sections are updated as per the changes we made in setting. If you select Longitudinal Section tab and click on the View button, then Longitudinal Section will be displayed. Longitudinal section gets created automatically in ESurvey section by reading 0 distance values for each cross section. So creating cross sections from Excel files is very easy in ESurvey section. If you want to import the data from CAD drawings, that is also very simple. The whole procedure of importing cross-section data from CAD is explained in another video. Creating cross-section template. ESurvey sections allows you to create cross-section templates for road, canal, railway line, and nala. For all the projects, creating a cross-section template has to be done in a similar format. These are some of the examples of cross-sections created using the cross-section templates defined in ESurvey section. A. PMGY road template. B. Railway cross-section for new construction. C. Railway cross-section for doubling work. D. National highway template designed using road design module. E. Canal. F. Nala. G. Canal section with soil strata data. Highly complex requirements are addressed using various options provided in ESurvey section. However, to understand template concepts, we will create a simple road cross-section template for PMGY road. Click on CS template item in toolbar. CS template master screen will pop up. Click on the triple dotted button next to CS template dropdown. Create a new template by name PMGY. Close Edit CS template name window. Select PMGY from CS template dropdown. The typical PMGY template will have a road width of 3.75 meters carriageway, 1.875 meters shoulder, and 1:1.5 tow line. We will create each one of these items. Click on the New button. Select Slope option from Type and give width as 1.875 and camber -2.5%. Similarly, we will create shoulder line with 1.875 with -3% camber. While creating tow line, we will select the type as gradient_W and provide width as 10 meters. We are specifying higher value 10 as the tow line normally to stop where it meets the ground. In ratio, we will provide value minus 1.5, which indicates ratio 1:1.5. Now we have defined left side of the road. We will also make provision for tow line in case of cutting section. Note that we have to define the tow line from point 3 only. While defining tow line for cutting, we have to also specify one more factor, reference. Reference value we have to specify as below, which means consider the tow line that we are defining now in case if the computed point is below ground. Now we have left side definition of road both for cutting and filling section. By clicking on mirror button, we can create the definition for right side of the road. Applying cross-section template for a section. Now that we have defined the template, it is time to test the template. Select any cross-section and select the CS template PMGY from the drop-down. Now we will provide a formation level here above the ground level and see how the result will be. Now we can note that cross-section is created by filling. Similarly, we will specify a level below the ground level and we can see that cross-section with cutting is created. Sometimes, if the value is very close to ground level, one side may come in cutting and the other side may cut in filling. ESurvey CAD will automatically handle such combinations. Now, you can see that a specific cross-section with ground level and respective cross-section applied is ready. You may note that the formation levels are created in a layer name, Layer 21. You can change the layer names by clicking on Settings button. Here, we will change Layer 1 as ground levels and Layer 21 as formation level. Now, values are there in Layer 1 and Layer 21. So, we will set Layer 1 and Layer 21 as area calculation layers. Now, if we refresh the cross-section, you may note that area between Layer 1 and Layer 21 is hatched. And you can also note that cross-section is updated with the respective area value also. Defining formation level. We have randomly specified the formation level while trying to understand how templates sit on ground level. For entire project, if we have to attach the template, then for each cross-section, we have to specify the formation level. This can be done in different ways. A. Derive formation level from existing center line. B. Give a constant value as formation level. C. Create formation level in software by providing chainage and level at all change points. D. Import formation level from Excel. E. Create a formation level in AutoCAD and import. Most popular among all these is creating a formation level in AutoCAD. We will select LS tab and view the longitudinal section. We will export the same to AutoCAD by clicking on CAD button. Now, we can draw formation level in AutoCAD. After drawing the longitudinal section, we can export it back to ESurvey CAD through LSEXP list program. LSEXP program will ask the drawing scale as inputs and export the line definition to ESurvey CAD. Select Design Formation option from CS Template Assembly menu and click on IMP CAD button to import the formation level defined in AutoCAD. Click the Update button to find formation level for each cross-section depending on the line we have defined. Select Apply CS Template item from toolbar and we will select PMGY template and apply to all the cross-sections in this project. With this, all the cross-sections are updated with PMGY template. Show printing of sections. We can print all the cross-sections of the project at a time. Click on Print item from toolbar. Click on CS Preview to generate all the cross-sections as a single drawing. Now, we can see that cross-sections are coming in one sheet, but they are organized randomly. Suppose, if you want to print one cross-section per drawing sheet, we can specify A4 template and change the settings in a way that per template one cross-section is set. Now all the cross-sections are arranged systematically and ready to print. This drawing can be exported to CAD, and in CAD, ESurvey CAD provides facility to print all the cross-sections with a single command. Show area and volume report. Once the drawings are generated, area and volume report will be ready. Select Reports icon from the toolbar and click on Area button to generate report having a detailed cross-section area for each cross-section. Click on Volume button to generate the volume report for the entire project. Note that ESurvey section allows you to generate area and volume reports in different methods like trapezoidal, net area, Simpson's 1/3 rule. Introduction to the design environment. The road design environment is basically fragmented into 5 tabs. 1. In Surface tab, you can analyze the surveyed points, create a TIN and make the corrections to the points as required. 2. In Horizontal tab, you can design the horizontal alignment, creating the multiple alignments, import other lines from the CAD packages as required for further analyzing, and creating a base design for strengthening and widening projects also. 3. In Vertical tab, you can design the vertical alignment and multiple vertical profiles. 4. In Cross-section tab, you can create the cross-sectional templates and apply them on the designed horizontal and vertical alignments. You can also extract the quantities of design and variable quantity layers. 5. In Plan tab, you can create the plan with all the designed nodes in the cross-section along with their elevations. Creating a surface. Point data from CAD package, Excel or CSV with X, Y and Z values can be imported to ESurvey CAD. These points are displayed along with surface TIN. The surface created can also be viewed and exported as a 3D surface to CAD package. Horizontal alignment. The tangent lines created in CAD package can be imported in the ESurvey CAD. All the imported tangents are designed for horizontal curves as per Indian Road Congress, IRC. Design standard settings can be set for a particular project based on terrain and classification of roads. The software will compute horizontal curves along with the transition for all the selected apex points as per IRC. In case if the software has not computed curves for some of the apex points, it is due to inadequate spacing between the adjacent curves, or apex points do not qualify for IRC design due to steep deflection angles. The software allows you to manually fit curve in such apex points. It may also be kindly noted that super elevation and extra widening is also designed here, which will be taken as the input in the cross-section tab. Vertical design. The tangent lines created in CAD package can be imported in the ESurvey CAD. All the imported tangents are designed for vertical curves as per Indian Road Congress, IRC. K-value setting and minimum length of the curve can be set for a particular project. The software will compute vertical curves for all the selected apex points as per IRC. In case if the software has not computed curves for some of the apex points, it is due to inadequate spacing between the adjacent curves, or apex points do not qualify for IRC. The software allows you to manually fit curve in such apex points. We can see all relevant band details with respect to horizontal and vertical design. Cross sections. Here we create the cross-sectional templates required for the project. These templates include various types like divided and undivided carriageway cross sections with different widths and different layers. It also facilitates to create the templates for strengthening and widening projects. Sub-assemblies like drain, service roads and customized sub-assemblies and blocks can be attached to the template. Further, upon creation of the required cross-section templates, they may be applied onto the horizontal and vertical alignments as already designed in the horizontal and vertical tabs. It may be noted that the super elevation and extra widening design parameters apply to the respective cross sections automatically. It also generates the comprehensive area and volume report. The key is that it calculates the design and variable layers separately. It also helps to modify the cross sections at a particular chainage or for a stretch of length. Plan. Here the complete plan is generated based on the horizontal alignment. It also captures and displays the critical edges of median, pavement, shoulders, toe, etc. from the cross sections as generated. This enables the user to directly have the ready plan without doing the editing job on the CAD package. Plan and profile generation. In CAD environment, you can generate plan and profile drawings automatically by operating just a few customized Lisp commands. This tool will be really handy as it saves lots of time. ESurvey Lisp is a collection of auto Lisp programs which are tailor-made to survey and infrastructure engineering drawings. There are around 200 Lisp in this collection and each of them serve as solution to small requirement, but collectively they will save a considerable amount of time while doing survey drawing editing. In this video, you will come to know about 8 to 9 Lisp commands. In this drawing, there is a boundary. If you wanted to mark the length of each segment of the boundary, type BCW at the command prompt. You can also run this command by selecting Measure Clockwise Bearing BCW in ESurvey Lisp menu under Polyline submenu. Provide any prefix, say A, and click a point to place the information table. BCW command will measure each segment of the polyline, mark respective bearing, and also creates a table containing this information in your CAD drawing itself. You can find the polyline direction by giving PLD command. By using DSL command, you can delete all the entities on the specific layer just by selecting one of the entities of that layer. We will switch to another example when you want to mark lot number for each parcel in a layout map. You have to use LOA command and click inside the parcel boundary in the order of numbering. Lisp will not only number the parcel, it also ensures that lot number are created exactly at the center of the parcel. Along with that, it finds out the area of each block and mark it. It will mark each side of the parcel. Isn't this utility a great time saver? In layout drawing, if you want to mark center line, use CELN command. This is helpful in creating road centuries depending on parcel boundaries. After marking the center for whole layout, you can find out the total length of the roads in layout. Use LSET command to set road center as the current layer. Use off command to switch off all the other layers other than road center layer. Use ETE command and select all center lines. ETE command will find out the total length of all the roads at a time. It will also create a CSV file which will have details of each road center line with its respective length, which can be opened in Excel. This is how ESurvey Lisp saves lot of your drawing editing time. We say little drops of water make a mighty ocean. In similar lines, ESurvey Lisp is a collection of 200 plus commands which can really save the drawing editing time in the survey and infrastructure engineering drawings. Any CAD drawing which is in UTM coordinate can be converted into KML file just by specifying zone value and hemisphere. In this example, you can see that there is a layout drawing which is opened in AutoCAD. Select Export to KML, KMLE from ESurvey CAD menu. Select the drawing objects which need to be converted into a KML file. Specify the zone value and hemisphere and specify that you want to open the KML directly in Google Earth. ESurvey KML will convert the drawing into Google Earth KML file and open it in Google Earth. You can convert Google Earth KML file into AutoCAD drawing. You can create KML file easily in Google Earth using tools provided such as Add Polygon, Add Path, or you may already have a KML file. Open ESurvey CAD. Select KML to CAD option from KML. Select the KML file that we have and then click on Convert. You can see that your KML file becomes an AutoCAD drawing. It can be exported to your CAD package for further modifications.
The ESurvey CAD software's elevation extraction solution is the simplest way to extract elevations from Google Earth Map API at any UTM coordinate. This application is created using Google Maps API and extracts elevations from any drawing file in UTM coordinates. First, open your drawing file with the map in UTM coordinates in your CAD package. If you don't have one, then you can create KML file of the location of your choice in Google Earth and convert the KML file into a CAD drawing using KML module of ESurvey CAD. In order to extract elevations from the ESurvey CAD's Google Earth module, you must have registered in www.esurveycad.com and you need to have sufficient credits. Since the drawing is in UTM coordinates, you need to set the datum. To do this, in command prompt, run the command SDS. In the window that opens, select datum, hemisphere, and zone and click Set. To mark a lat long block along the selected alignment, you need to follow the simple steps mentioned below. Select an alignment as shown. In Google Earth in ESurvey CAD menu, select Mark Lat Long Block along selected alignment, MLA, or run MLA command at the command prompt. Enter the required chainage distance. Mention if you need to include the change points. Then select the alignment line. The elevations will be marked as shown. Next, mark lat long block for a selected boundary. In Google Earth menu item in the ESurvey CAD menu, select Mark Lat Long Block for selected boundary MLB or run MLB command at the command prompt. Mention if you want to round off the grid point coordinates and if yes, enter the multiple to which the grid point coordinates will be rounded. Select the boundary polyline. The elevations will be marked as shown. Now, you can extract the marked elevations from Google Earth. To extract the elevations from Google Earth, select the option Extract Elevation from Google Earth GEE or run the GEE command at the command prompt. Note that elevation extraction is a paid service and available only for registered users at www.esurveycad.com. You should have enough credits to extract elevations from Google Earth. You need to first enter your login credentials. Select the lat long blocks for which you want to extract the elevations. A message will be shown with information about the number of elevations that you will be extracting and total number of credits that will be deducted. To confirm, click OK and then in the command prompt type Yes to continue to extract the elevations. All the elevations will be extracted and placed at the respective UTM coordinates. In this way, you can extract the elevations of the area within the desired boundary or of the desired alignment. In this video, you learned how to extract elevations from Google Earth. Similarly, you may also download images of various places from Google Earth using ESurvey CAD, which is explained in another video.
Google Earth is a geo-browser. Google Earth implementation has brought in a new dimension for visualization. This has created the opportunity for surveyors to present their data in geographic coordinate systems. You can mark locations and paths in Google Earth and save it as a KML file. These files cannot be opened in AutoCAD directly, because AutoCAD works on the Cartesian coordinate system. You can use the KML to CAD module of ESurvey CAD to convert all the point information present in KML, that is latitude-longitude, to the respective UTM and prepare it as a DXF file that can be opened in CAD packages like AutoCAD. Google Earth is not a friendly environment to trace feature lines. CAD packages offer excellent features to work with images. Considering this requirement, eSurveying SoftTech has developed a solution using which you can insert Google Earth images in your CAD package. Before you proceed, you need to know that Google Earth images come in different types: road, satellite, and hybrid. First, you need to decide which type of map you want to download. Using the Set Map Type command, you can set the type of image you want to download. You can download Google Earth images of different resolutions. At zoom level 1, 640 x 640 size image fits the whole world map. At zoom level 2, 4 images make the world map. Similarly, at higher zoom levels, you get better resolution images. Depending on your project requirement, you may download the images. Most of our users download images at zoom level 18 and 19. At zoom level 18, one image is 275 meters by 275 meters. Before downloading the image, your drawing entities should be in UTM coordinates. Using SDS command, you can set the map datum, zone number, and hemisphere. Normally, images are downloaded along an alignment or for a given boundary. Using MIA command, you can mark image tiles along an alignment. Similarly, using MIB command, you can mark image tiles for a given boundary. Depending upon the zoom level you specify, the boundaries are marked. You may delete some of the boundaries, or you may manually add more closed polygons in image box layer. You have the liberty to alter polylines to different shapes, but please ensure that width or height of the polygon does not cross the maximum distance allowed for a given zoom level. Once you are ready, you may use GEI command from the Google Earth submenu of eSurvey CAD menu and download the images. Upon execution of the GEI command, you will be asked for your credentials from the esurveycad.com registration. Note that these images are downloaded from Google Earth using paid APIs. So downloading each image will cost you, for which you will have to buy credits from esurveycad.com before you actually download the images. Once you provide the login credentials of www.esurveycad.com, images will be downloaded and georeferenced to the respective UTM coordinates. Similarly, you may also download elevations of various points from Google Earth using eSurvey CAD. Thank you for watching this video. If you're working in the infrastructure industry, please don't forget to subscribe to our channel. We regularly add informative videos about infrastructure design and engineering solutions. Please contact us at +91 944 9599 709 or 080 2349 1717 in case if you want to try the software for free. Visit www.esurveying.net in case if you require any further information.